Hi everyone, we're on the last section, section 17E of the quadratics unit, and we're looking at quadratic optimization. So when we're finding the maximum or the minimum value of a function, what we're really doing is we're looking at the optimization. Now if our value of the a in the quadratic is greater than 0, then that means, as we already know, that the minimum value of y occurs at x equaling negative b over 2a. So we have an axis of symmetry, which is found by doing negative b over 2a, and we can figure out our vertex from that, so that we would have a minimum value for the vertex. And if our value of a was less than 0, then our graph would be facing concave down, which means that we would have a maximum value that would be occurring at x equaling negative b over 2a. All right, so the question that we can just take a look at very quickly, is just a quick review, is to find the maximum or minimum value of the following quadratic functions and the corresponding value of x. All right, so if I want to find the maximum or minimum value of the following functions, well, that means that I'm looking for the vertex. So that means I'm looking for the highest point or the lowest point. So given, let's take a look at the first example. We've got y equals x squared plus x minus 3. Well, I know my value of a is equal to 1, my value of b happens to be equal to 1, and my value of c is equal to negative 3. If I do x is equal to negative b divided by 2a, I end up getting negative 1 divided by 2 times 1, which makes it negative 1/2. Okay, so that means that my x value of the vertex is equal to negative 1/2. Now to find the corresponding y value of the vertex, all I do is I substitute the x value, which I found to be negative 1/2, into the equation y equals x squared plus x minus 3. So I am substituting my x value into the function, into the equation, in order to get my corresponding y value. So I'll say y is equal to negative 1/2 squared plus negative 1/2 minus 3, and that gives us 1/4 minus 1/2 minus 3, which in turn gives us 1/4 minus 2/4, and then it's minus 12/4. And that gives us a final answer of negative 14 plus 1, which is negative 13 over 4. Therefore, our vertex, in this case, is going to be found at negative 1/2 and negative 13/4. Okay, let's take a look at the second example. The second example, we have to make sure that we put it in the correct order, so that we've got negative y equaling negative 2x squared plus 3x plus 3. So that means that my value of a is equal to negative 2, and my value of b is equal to 3. And so x is equal to negative b, all divided by 2a, which makes it negative 2 divided by 2 times 3, and that gives us 2/6, which is equal to 1/3. All right, so once I have figured out that my value, or my x value of the vertex, is 1/3, I then just substitute it into the original into the equation, y equals, to find the y value of the vertex. So I will have y equals negative 2 times 1/3 squared plus 3 times 1/3 plus 3, so that I get negative 2 over 9 plus 1 plus 3. So it's negative 2/9 plus 4, and if I get a common denominator, it goes to negative 2/9 plus 36/9, which gives me 34/9. So that I have a final answer here of the vertex being equal to 1/3 and 34/9. Okay. Next question. Let's take a look at the next question, which is a real-world situation type problem. So it says that we've got the height h meters of a ball. The height h meters of a ball t seconds after it's hit vertically upwards, and is given by this formula, h of t equals 40t minus 5t squared. So the question is asking, how long does it take for the ball to reach its maximum height? Now, before we can do anything with this, we need to understand, I like to visualize what the graph is what the graph looks like. So what that means is, I know that along the x-axis, I'm going to have the time in seconds, and along the y-axis, I have the height of the ball as it's hit vertically upwards, and the height is h of t. Okay? So that I know that when I rewrite the equation, it's rewritten as h of t is equal to, and I'm putting it in order from highest degree to smallest degree. So it's negative 5t squared plus 40t. This tells me automatically that my graph is facing downwards, which means that I will have a maximum point. So these are all things that I keep into consideration as I start my problem. So the question is asking, how long is it going to take for the ball to reach its maximum height? Well, I'm assuming that the graph is going to look something like this. Okay, that's just an assumption. It starts at time equaling 0 on the ground, I'm assuming. Okay, and so I need to find out when it reaches its maximum height. So the way I'm going to do that is, the t is my x, the time, and the y is my height. Therefore, I'm going to say h of t, I'm going to take my axis of symmetry formula, x is equal to negative b over 2a, which will become negative 5, all divided by, oops, made a mistake there. It's negative 40 divided by 2 times negative 5. And so that will give me negative 40 divided by negative 10, which makes it 4. So what does that 4 stand for? It's the x value. The x value stands for 4 seconds. So it's along the x-axis. It's 4 seconds. So it reaches, the ball reaches its maximum height. So I'm just going to put this down here. It reaches its maximum height at 4 seconds. Okay? So in order to figure out, so that answers my first question, how long does it take for the ball to reach the maximum height? Well, because x is referring to the x-axis, and along the x-axis we have time, then that means that it takes 4 seconds for the ball to reach its maximum height. All right, so in part B, we are asked, well, what is the maximum height that the ball reaches? So that means that it's asking for the y value for the height, because the height is our y value on the parabola, or in this graph. So that in order to figure that out, I do h at 4 seconds has to equal negative 5 times 4 squared plus 40 times 4. So that ends up giving me 16 times negative 5, which is 80, or negative 80, plus 160, and that gives me 80. So that means it's 80, I believe it is, in meters, if I'm not mistaken. No, it doesn't say. Okay. Yes, it is. 80 meters. All right, so I now know that my vertex, then the vertex is found at 4 seconds and 80 meters. So it reaches its maximum height at 4 seconds, and that maximum height reached is 80 meters. Okay, so the maximum height here is 80 meters. Now, in part C, the final part of the question is asking us, how long does it take for the ball to hit the ground? Well, if it took 4 seconds for the ball to go up, and again, this is not physics, so we are not keeping into account any gravitation. So we're not keeping into account any gravity. We're not looking for any forces against the ground, any forces with the ground. We're not keeping into account any of those things. And therefore, if it took 4 seconds to reach the maximum, for maximum height, then it's going to be 4 seconds to fall to the ground. Therefore, the total amount of time is going to be 8 seconds. Time will be 8 seconds. Okay, so that's another example of a question that we could be looking at. Now, another way that this question could have been answered would have been to say, since we were looking for the x-intercepts here, then to find the x-intercepts, you let y equal 0. So if I let y equal 0 in negative 5t squared plus 40t, and I say 0 is equal to negative 5t bracket t minus 8, then I would end up getting that negative 5t is equal to 0, or t minus 8 equals 0, so that t would either be equal to 0 or t would be equal to 8. So I could have figured this out algebraically, or I could have figured it out actually logically, just thinking it through logically and saying, well, the halfway point was 4, and therefore 4 plus 4 gives me 8. Okay, we're going to look at this last question, which is example 17, exercise 17, number 4. And the question says that the hourly profit in P dollars obtained from operating a fleet of N taxis is given by P sub N equals 120 N minus 200 minus 2N squared. Okay, so the first thing I would do is rewrite this as P of N is equal to negative 2N squared plus 120N minus 200. Okay, where, again, I would try to picture what the graph looks like. So I know that the graph has a y-intercept. It has a y-intercept at negative 200. So let's assume this is negative 200. And I know that the graph is going to be facing downwards, simply because I have a negative in front of the n squared here. So I know it's concave down, it's opening down. And I know that the profit is going to be, the profit is a function of the number of cabs. So that means that along the y I have my profit, and along the x I have my number of cabs. So my independent variable is the number of cabs, and the dependent variable is the amount of money that I'm going to be making from the cabs, or the number of cabs that are called, or taxis. Okay, so the first question then asks in part A, it says, what number of taxis gives the maximum hourly profit? So again, we're looking at x equals negative b over 2a, which is equal to negative 120 divided by 2 times negative 2, and that gives us 120 divided by 4, which equals 30. Okay? So we know that the number of taxis that gives the maximum profit are 30 taxis. That's my value of the x. So to find the maximum profit that you are making when you have 30 cabs, what you do is you replace the value of, you substitute the value of x equaling 30 into the function y equals, or p sub n, p at 30 is equal to 120 is equal to negative 2n squared plus 120n minus 200, which equals negative 2 times 30 squared plus 120 times 30 minus 200. And we end up getting as a final answer $1,600. So that's the amount of money we would be getting, would be $1,600 with profit with 30 cabs. Okay, the third part of the question asks, how much money is lost per hour if no cabs are on the road? Well, that means that our value of the x is equal to 0. So if x is equal to 0, that means that we're looking at the y-intercept. And the y-intercept happens to be in our equation negative 200. Now it's negative 200 because we're losing money. So therefore, if no taxis are on the road, if there are no taxis on the road, you are losing $200. Okay? And the alternative way of doing this would be to just put in P at number of cabs being equal to 0 is equal to negative 2 times 0 squared plus 120 times 0 minus 200. And that would give us negative 200. So you would lose $200. Okay, so that's the end of this lesson. You will have your homework. Your work that you'll be working on in class is right here, and I'll make sure that we'll be doing this in class next time. See you next time. Thanks.